Hello, everyone. Welcome back to the continuation of our video on electrolysis. Right? I hope you guys are doing well. My friends in India, in USA, in New Jersey, in Florida, I say thank you for your support. And my friends, particularly from India, God bless you guys. Celebrate you guys. Now, we're going to be talking about calculation on electrolysis, which is very particular for examinations for both A level and O level. And I'm going to be teaching you my own method. For my friends all over the world, there are many other methods in solving questions, but my methods are much more are broken down so that you can understand where you are coming from. Now, these two questions that we're going to be solving. Now, the question says, how many Faradays of electricity are required to liberate 9 grams of aluminium, giving you the relative atomic mass of aluminium to be 27. So it's actually very simple. I keep on telling students, nothing in life is actually difficult. You should begin to change your orientation, your mindset. There is no exam on earth that cannot be passed. That someone can pass it very well and score good grades. Then you in particular, yes, you can do much more better. You have to begin to think of it and be it. Now follow the way I'll be solving for you, right? And if you understood what I'm teaching you now, you can drop a comment below and say thank you. So let's just go. Now, we should understand the breakdown. For example, don't forget that 1 mole of sodium ion, is equivalent to 1 mole. It's equal to, okay, 1 mole of what now? Electrons, which is also equivalent to what now? 1 farad. But 1 mole of magnesium ion, please take note of the charge, is equivalent to or is equal to 2 mole. Remember this charge here, magnesium here, look at this charge here. You pick the charge as the mole. 2 mole of electrons, which is equal to what now? 2 farad. So be very careful. So if I'm having 1 mole of aluminium 3 plus, take note, is equivalent to this 3 here, power here, this charge here, 3 mole of the electrons, which is equivalent to what now? 3 what now? Farad. So there are some persons might want to give you shortcut, but I want to actually break it down to the barest minimum, so that anywhere you see it, you can understand the chronology or the principle that is following it. As you can understand here, you see now, if you understand this part now, when we are solving questions, you'll be giving it the master's approach. Can we continue? Okay. Now, as I erase the board to start solving for you this question, you should understand. Now, say how many farad of electricity are required to liberate 9 grams of aluminium. We'll start with the statement I said. Now, take note. 1 mole of aluminium. Remember, the charge of aluminium, you should know these valencies of elements. 1 mole of aluminium, remember that aluminium is charged. It has a charge of +3. You should know. 1 mole of aluminium ion is equivalent to, remember, I'm working in farad, so it's equivalent to what now? 3 what now? Farad. Now they're not telling you now how many farad of electricity, how many farad, which is what I'm looking for, how many farad of electricity are required to liberate 9 grams of aluminium. What do? I will have to convert this my 9 grams of aluminium to mole. Do not forget that number of mole N is equal to mass over molar mass. The mass of aluminium here is 9. The molar mass of aluminium here is 27. When you divide, let's go, 9 divided by 27 to give me 0.33 mole of aluminium will give me what? So what do we do? It's simple. I just cross multiply. So x farad now, remember, x times 1 is 1. 0.33 times 3, right? 0.33 times 3 will be equal to times 3 will give me 1 mole. Sorry, 1 farad. That is all. Final answer. We got this statement from the first analysis I gave, right? That 1 mole of aluminium ion is equivalent to 3 farad, which is 3 mole of electrons. So that's it. Then 0.3 mole of aluminium ion will be equal to what farad? Remember, we converted this diagram here to become the mole here. That is all. So we can move to the next question. As I can move to the next question, please take note. Now, when we move to the next question, it's actually very simple. The same method. What does the question say? The question says, when 0.2 farad of electricity is passed through a solution of copper 2 sulfate, because copper has more than one valency, because it is a transition element. Copper has +1 and +2. But in this compound now, it is +2. Because sulfate is -2, copper must be +2 to equal the charges. So +2. The mass of copper deposited on the cathode would be simple, of course. How do we go? How do we do it? Simple. 1 mole of copper 2 ion, right, is equivalent to what now? 2 farad. How did I get this 2 farad? From the charge here, right? Now, I'm to first of all look for the mole first. The mole of copper 2 ion, they've already told you that it was what now? 0.2 farad. Is that clear? And when I cross multiply, x mole is now equal to what now? Okay, when I cross multiply, it will become, okay, this times this, okay, this times this, so it should now become what now? Let's break it down. 0.2 divided by what now? 2, which will now be equal to 0.2 divided by 2 to give me 0.1 mole. 0.1 mole, right? Now, if I'm having 0.1 mole, remember, the question did not ask you for mole, rather the mass of copper deposited. And you are aware that number of mole N is equal to mass over molar mass. I was given the mole and had to find for the mass. What connects mole and mass is molar mass. So that it will now become molar mass, mass is now equal to N multiplied by molar mass, which is 0.1 times 64. And the final answer, 0.1 multiplied by 64, final answer is now 6.4 gram. And that is the final answer to this question. Very, very simple. 1 mole of copper 2 ion is equivalent to 2 farad from the statement of the copper. 1 mole of copper 2 ion is equivalent to 2 farad. The x mole of copper 2 ion is equivalent to 0.2 farad from what we are given. Just cross multiply, you get 0.1. I'm looking for the mass, just do it. And that is all. Now this is the phase 1 of this question. We will move to another phase or another case study of the calculation. Thank you and God bless you. Kudos.